So how do you sketch these functions? So we start with f of x equal to 1 plus the square root of 2x plus 1. Okay, so when you're sketching square roots here, make sure that you don't have a number inside the square root here, in front of x rather. So I'm first going to factorize it. We're going to have 2x divided by 2 is x plus 1 over 2, like that. Okay, you factorize it. Now after you factorize it, it's like, note that if you have the square root of ab, it's the same as the square root of a times the square root of b. So I'll separate the 2 and this. So I'm going to have 1 plus the square root of 2 square root of x minus 1 over 2. Okay, that's what I'm having. Now from here, you can now start writing your data. So your data, your first data is your parent graph, right? Your parent graph. So your parent graph, you equate this to, your parent graph, you look at the state of x. Y is x is inside the square root. So that's a parent graph. After that, you look at the horizontal shift. Now what do you do with the horizontal shift? You equate this to 0. Let x minus 1 over 2 be equal to 0 and x will be equal to 1 over 2. After the horizontal shift, you look for the vertical shift. Alright, what is a vertical shift? A vertical shift is a number away from your function. So this is our function, and the number away is our vertical shift, which is y is equal to 1. After the vertical shift, what does this number in front represent? So that number, we're going to have it as a vertical stretch. In other words, it will stretch vertically. Why is it stretching vertically? If you have vertical stretch by square root of 2. Okay, why is it stretching vertically by the square root of 2? Because the square root of 2 is bigger than 1. So if you have something like this, b f of x, right? If b is greater than 1, meaning you're going to have a vertical stretch. If b is less than 1, you're going to have a vertical, vertical, it will be compressed. Your graph will be compressed. Okay, it will be compressed. So if you have something like 0.5, or let me say 1 over 2 square root of x minus 1, right? Since this is less than 1, meaning you're going to have a compression. Alright, compression by half. Okay, but if it's a number greater than 1, maybe say 3 over 2 is bigger than 1, then it's going to be vertically stretched. Square root of 2 is bigger than 1 to be vertically stretched. By what? To be stretched by this. So a graph can either be vertically stretched by this or compressed by the same. Okay, that's the way it is. So we have every information there, so we can sketch. So I'll sketch each of them separately. Okay, so I'll start with the first one. General graph. How does the square root of x look like? The square root of x looks like this. Okay, after that we mark this. We go to the shift of half. Okay, so I'm sketching now half. To move from 0 to half, so to go to half, you can approximate your half as a line here. It can be in crosses, alright, half. Alright, you can approximate as your half. Just wait a minute. Okay, you can approximate your half as here, isn't it? So I mean your graph will no longer start from 0, but it will start at half. Alright, like that. And it won't be taller than the other one because I've just moved horizontally. Then this one is gone. We go to the vertical shift of y is equal to 1. Y is equal to 1 is always above. It's always above the square root. So this is 1. So it will move from here, which is half. It will go vertically on top to here. So this was a shift. Y is equal to the shift. This is y is equal to the shift plus 1. Okay, plus 1 there. So we're done even with this one. Now we need to do this one. So now guys, you have to know if your graph is like this, right? If it is stretching vertically, it will be on top like this. If it will be compressed, it will go beneath that one. So since it's stretching vertically, it will be on top of this one, so it will be like this. This is my graph. This is y is equal to 1 plus square root of 2 square root of x plus, is it x minus 1 over 2. Okay, that's a graph. All right, let's go to the second one. The second one is straightforward. Second one is straightforward. So we have f of x is equal to square root of x plus 3 plus 2. Now since x is independent, you can just start parent graph, because x is independent, so it will be square root of x. You don't just need a number in front of x. Secondly, it's horizontal shift. Alright, horizontal shift. What do you do with horizontal shift? You equate this to 0. Let x plus 3 be equal to 0 and x is equal to negative 3. After this, what do? You go to the vertical stretch. Alright, or vertical shift. What is our vertical shift? Our vertical shift is y is equal to 2. Yeah. Is there anything else? Nothing else. Okay, so this will be the first one, will be this. Okay, then it will go to negative 3. So if this is our 0, negative 3 is found here. This is line x is equal to negative 3. So it will start from negative 3. So this one is a original. This one is a shift. Y is equal to x plus 3. Okay. And we know that this is y-axis, this is the x. So to know this point, we have to replace 0 here where there is x. So 0 plus 3 is 3, square root of 3. Then after that, it shifts to 2. Now guys, 2 is above the square root of 3. So the 2 will be here. This is 2 there, right? So instead of a graph starting from here, it will go to 2 now. It will start from here. So it will go like this. Okay, to know this point, you just add 2 to this one, so it will be the square root of 3 plus 2. So this graph is y is equal to square root of x plus 3 plus 2. Okay, and this is the y-intercept. You can replace the 0 there. You're going to still have square root of 3 plus 2. That's how you sketch that. Very simple thing, isn't it? Feel free to try out the video for the third one. Very good question. Very good question for the third one. Very good question. Okay, the third one we have f of x is equal to 1 plus the square root of x over 2. So now guys, remember what I said, you can factorize. Inside here you can factorize the 1 over 2 because you need x to be independent. Like that. So this will be 1 plus, then this will be the square root of 1 over 2 times the square root of x. So this will be 1 plus, what is the square root of 1? It is 1 over square root of 2 times the square root of x. Now notice, there is no number in front of x. That's what I wanted to achieve. So now I can start with the parent graph. Our parent graph will be y is equal to the square root of x. Secondly, is there any horizontal shift? Our horizontal shift, yes, there is. Horizontal shift is x equal to 0. You equate this to 0. After that, do we have a vertical shift? Yes, we do. What is our vertical shift? Our vertical shift is a number away from the square root. Then after that, what does this represent? Is this bigger than 1 or less than 1? This is less than 1, isn't it? So we're going to have a compression, right, by 1 over the square root of 2. So we have everything. Now we can sketch. Okay, y and x then. So we can start with the general graph or the parent graph, square root of x. So this is y is equal to the square root of x. You have sketched. Is it shifting anywhere? No, it's remaining at 0, and then it will shift vertically by 1. So you draw line 1 on top, always on top. So this one will move from 0 to go to 1. This is y is equal to 1 plus the square root of x. Let me just draw it nicely. Okay, so this is y is equal to 1 plus the square root of x. Okay, now compression means the graph will be inside. If it was stretched vertical, it would be above this one. Now since it's compressed inside, right, it is compressed. Compression means inside. So a graph, your final graph will be this. This here is y is equal to 1 plus 1 over the square root of 2 square root of x. That's a graph. Okay, that's the way it is. Can try out the fourth one. Feel free to pause the video and try out the fourth one. We have f of x is equal to 3 plus or 2 plus 3 square root of negative x plus 1. So first thing is first, is x independent? Yes, x is independent. Or write it as 1 minus x. Is there any number in front of x? No, there's no number. So your parent graph, alright, your parent graph will be y is equal to negative x. Okay. Secondly, your horizontal shift. Alright, your horizontal shift. What will be your horizontal shift? You equate this to 0. After this, you go to the vertical shift. What is a vertical shift? A vertical shift is a number away from a function, which is 2. And after this, you go to you look at other things. What does this 3 represent? The 3, is 3 greater than 1? Yes. So it represents a vertical stretch. By what? By 3. So you have everything. You can now sketch. So you have negative square root of x goes this side. Okay. So you start from 0. After this it goes to 1. Line 1 is this one. So to move from here to go to there. So this was the square root of course negative. This is a shift. Y is equal to square root of 1 minus x. If you want to know this point, you place 0 there. It's going to be 1 minus 0. Square root of 1 is 1. So this is 1. Okay. After that it goes to 2. So you can draw 2 here. So to move from 1 to go to 2. So this graph here is 1 is equal to 2 plus square root of 1 minus x. If you want to know this point, you replace a 0 there. So this will be 3, isn't it? Then what's the last thing? It's a stretch by 3. So stretch by 3 means multiply this by 3. 3 times 3 is what? 9. So it will go and cut at 9. So your graph will go now like this. Yeah, then cut at 9. Okay, so this is y is equal to 2 plus 3 square root of 1 minus x. That's how you go about it. Okay. Let's do question 5. Question 5. F of x is equal to 1 minus 3 square root of x minus 1 over 2. First question is first. Is x independent? By independent I mean, is there a number in front of x? No, there's no number, so it's independent. So you find the parent graph if it is independent. So a parent graph will be square root of x, isn't it? The other one, it was negative because x was negative. Okay, So this is that. After that, you go to the horizontal shift. Alright, horizontal shift. You say let x minus 1 over 2 be equal to 0 and x will be equal to 1 over 2. After the horizontal shift, you go to the vertical shift. Alright, vertical shift. Vertical shift is a number away from the square root, which is 1. After the vertical shift, what is left is 3. Okay, not negative 3, but 3. So 3 is greater than 1, isn't it? So you say vertical stretch. Alright, by what? By 3. Okay, then what does this negative represent? Negative represents reflection. So reflection, when you see a negative in front of a function, it means reflection, not inside but outside. So what do you say about reflection? Reflection, you just write the original function. That's it, nothing else. You'll see what will happen during reflection. So you have this, okay? This is x and this is y. So first thing is first, prime graph square root of x. Okay, so we are done. We go to shift negative half, guys. So if this is 0, where can we find half? It's here. So this is y is equal to the shift. Is it negative half? Oh, it's positive half. Sorry, positive half. Positive half. Sorry. It's positive half, isn't it? Why can we find half? It's a side. So a graph will start from here. It won't be taller than the other one, just be the same. So this is a shift. Y is equal to x minus half. So this one is gone. Then it goes to 1. 1 should be always on top of the square roots. So this is your 1, meaning to move from here half, it will go to 1. So this is y is equal to 1 plus the shift. Then you go to a stretch by 3. So since it's stretching, it will just be on top. It will be taller there, right? Like that. So this is y is equal to 1 plus 3. Notice it's plus, it has not yet reflected. Okay. Now it has to reflect. We go to reflection now. So how is it going to reflect? So this is what will happen, yeah? So this one will just reflect, or reflect like that. Alright, or reflect. So this is a graph. Instead of this, it will just reflect down. Okay, it will reflect down. Alright, it will reflect like that. Alright, now here's the thing. I'll draw it using a different ink. If you want, you can even know how it to cut, because if it will reflect down like this, it somehow it will cut the x-intercept. So if you want to know where to cut the intercept, you have your original function, which is a reflection here, x minus half, right? Okay, that's the original function. You can replace that as 0. 1 minus 3 square root of x minus half. Take everything this side, it's going to be that. Alright, then square both sides. You're going to have 9x minus half is equal to 1. Then this will be 9x minus 9 over 2 is equal to 1. Then this will be 9x is equal to 1 plus 9 over 2. This is 9x is equal to 11 over 2. Divide by 9, so x is equal to 11 over 2 times 1 over 9, which is 11 over 18. So in a way, you can draw this. If this goes, it will cut at 11 over 13 like that. It will cut there. Okay, that's how it will move in that direction. So this will be somewhere like 11 over 13. yeah, which is 11 over 18. Yeah, 11 over 18, because this is 18, which is above 0.5. okay, which is above 0.5. yes, so this one will be 11 over 18, stuff like that. If let me check it, if we square both sides, okay, if this one goes aside, we're going to have this, then we square both sides. This will be 9, this will be x, this will be 1, okay, this will be 9x minus that, this will be 2, 11, okay, over 2 times 1 over 2, x will be okay, it's all right. So that will be your graph. This will be a sort of your reflection then. Okay, now let's try the last video. Feel free to pause and try the last video. Feel free pause and try the last video. Okay, try out the last video. You can try out the last video. So we have f of x is equal to square root of 2x minus 1 minus 3. Firstly, factorize x, or factorize 2. This will be x minus half. Okay, minus 3 there. Then this will be a square root of 2, square root of x minus half minus 3. So your parent graph will be y is equal to square root of x. Your horizontal, alright, shift will be let x minus 1 over 2 be equal to 0, x is equal to 1 over 2. Then your vertical shift, what will be a vertical shift? Your vertical shift will be y is equal to negative 3, this number away. Then there's a square root of 2 there, which represents vertical stretch. Why? Because it's bigger than 1. If it was less than 1, would have had a compression, and the compression always goes inside. The shift, the vertical shift, always goes outside. That if we're dealing with square roots. So we're going to have this. This is y is equal to square root of x. Check. Then we go to half. Where can we find half? Half is somewhere here. We're going to approximate. So it will start from here and it will join its friend there. So this is a shift. After that it goes to negative 3. It will be there, right? So it will go to minus 3, sort of. This is y is equal to square root of x minus half minus 3. Okay, now here's the thing. So we can't draw it, we can't necessarily guess that it will be inside. Let's check if it will cut any x-intercept. So we have y is equal to x minus 1 over 2, right? Minus 3. That's what we're sketching there, right? Because it has shifted down there. So let's find the x-intercept. In the x-intercept, y is 0. Okay. Take the 3 this side. Then square both sides. Okay. We're going to have 9 is equal to x minus half. Take the negative half this side. Then this will be 19 over 2. So meaning it will cut at 19 over 2. So if I'm going to draw it, I'm going to draw it in a way that is very nice. Okay, so if this is my 0, approximate that negative 3 is here. And I'll use different ink so that it will go like this. It will first start and then go and cut here. So this point is cutting now, says it's 19 over 2. Okay. So this graph is y is equal to square root of x minus half, right? Minus 3. That is without the stretch. Now let's go to the stretch. Now notice it has stretched now by 3. Okay, it has stretched now by 3. So what are we going to do now since there's a stretch? So since there's a stretch, meaning we're dealing with this function, we're dealing with y is equal to square root of 2 square root of x minus 1 over 2 minus 3, which is the same as the original equation, 2x, which is the same as the original equation. So let's solve for x. This one will go the other side, then square, this will be 9 is equal to 2x minus 1. So this will be 9 plus 1 is equal to 2x. So 2x is equal to 10. So x is equal to 5. So now notice 19 over 2 is 8 point something. Now it will cut at 5. So it will come and cut at 5 here. So meaning your graph will be this. Have you seen? Wonder I said for the vertical stretch it will be on top of this one. So this is this one. Okay, then our normal graph is this one now. Y to cut at 5. Right, to cut at 5. So this is 5, and this graph is the original function. Sometimes you can take the what's this, the stretch as the original function. That's in the positive format without the negative in front. Yeah, that's the way it is. So that's how it goes here. Okay, I know a vertical stretch, if there is a y value there, I would multiply by y, but notice here it's in the x. What do? You just take the original equation and solve for it. Alright, and that's the last thing you're sketching. There's no reflection here. So yeah, and that's to be in the positive format like this. There was a plus, you had y is equal to, there was a plus here, square root of 2 x minus 1 over 2 minus 1. There was a plus here, right? So it's okay for me to just take the original equation. It's okay. Sorry. In a sense that square root of 2 square root of x minus 1 over 2. Have you noticed this is the same as the square root of a times the square root of b. The answer is the square root of ab. So this is the same as the square root of 2x minus half. So if you multiply this is the same as 2x minus 1. That's it. And then minus 3 outside here equal to 0. Then solve for x. That's how you go about these questions. I hope they have been of help.